Okay, hello Cloud Gurus and welcome to this lecture. In this lecture we're going to talk about RDS and we're going to look at backups, multiple availability zones, read replicas, and then I'm just going to compare it to DynamoDB and where you would use RDS versus DynamoDB. So let's start with backups, and there's two different types of backups for AWS when it comes to RDS. These are automated backups and then database snapshots. So we'll start with automated backups, and basically they allow you to recover your database to any point in time within a particular retention period. And the retention period can be anywhere from 1 day all the way up to 35 days. And I think by default when you create a RDS database, it's 7 days retention period is selected for you automatically. Now automated backups basically take a full daily snapshot, and they also store transaction logs throughout the day. And when you do a recovery, what happens is AWS will go in and choose the most recent daily backup and then apply the transaction logs to that backup that are relevant to that day. And what's cool about this is it allows you to do a point-in-time recovery down to a second within that retention period. So you can go back 35 days and you can say, okay, on Friday afternoon at 2:35 p.m. and 45 seconds, I want to recover my database to that point in time. And this is all built into RDS by default, so you don't need to really worry about this. You just turn on automated backups and RDS will do all the heavy lifting for you. Automated backups are enabled by default. The backup data is stored in S3 and you get free storage equal to the size of your database. So if you have an RDS instance that has a 10 gig instance size, you get 10 gigs worth of storage space on S3. Backups are taken within a defined window, so you define your backup window, and you might want to do this when your database is not going to be used very heavily, so it might be 3 a.m. Every morning. And during the backup window, basically, if you're going to go and when it does the automated backup, your storage I/O may be suspended while your database is being backed up, and you may experience elevated latency. So again, it's best practice to choose a backup window when your database is going to not being utilized very heavily. So moving on to snapshots. Now snapshots are different from automated backups in that snapshots are done manually. So they have to be user initiated and you have to go into the console and do a snapshot. And they're stored even after you delete the original RDS instance. The automated backups will be automatically deleted if you go on and delete that RDS instance, but it will prompt you to do a final database backup, which it can store as well. And one last thing with both automated backups and with database snapshots is whenever you restore either an automatic backup or a manual snapshot, the restored version of the database is always going to come from a new, it will always be a new RDS instance with a new DNS endpoint. Now just moving on to encryption. So encryption at rest is supported for RDS, but it's only supported for MySQL, Oracle, SQL Server, PostgreSQL, and MariaDB. Encryption is done using the AWS Key Management Service, and once a RDS instance is encrypted, the data stored at rest in the underlying storage is encrypted, as well as the automatic backups, the read replicas, and the snapshots. At the present time, encrypting an existing DB instance is not supported, so to use Amazon RDS encryption for an existing database, what you have to do is create a database instance with encryption enabled and then migrate your data into it. So you have to create an entirely new database instance. Okay, so if we have a look here, I've logged into the RDS console and I've gone to my RDS instance, which I created in the last lecture. And we can see here that I can go through my instance actions and I can do a couple of things. So I can take a snapshot, and this is what I mean by it being user initiated. I can go across here and we'll just call this a Cloud Guru snapshot. And this is me taking a manual snapshot, and go ahead and hit take snapshot, and that will now be creating. Now you can see here, and we're actually clicked over here on the snapshot section. You can see here, these are my automatic backups from my RDS instance. It's been going since March the 7th. So it's been going for 10 days now. And I can do a point in time recovery for any of these snapshots if I wanted. So let's say I want to go back to March the 12th. I would click in here. And I could go up here and go restore snapshot, and I can go all the way down. It does give it a new, when you restore a snapshot, it does create a new database. So you have to give it a new DB instance identifier. So I'm going to say a Cloud Guru March 12th, and then I'm just going to scroll down. I'm going to leave everything as default settings. So do I want this publicly accessible? I can say yes. When I'm restoring a snapshot, I also get the option as to whether or not I want this to be a multi-AZ deployment or not. I'm just going to say no for now. And that's pretty much it. I'm going to leave all the rest as default settings. I can say to restore it into a particular availability zone if I want, but I don't. I'm going to go ahead and hit restore. Now it's important to remember that this is just restoring that full snapshot that was taken during my backup window. If I want to go and do a point in time restoration though, I can go up here and I can go over to my iCloud Guru instance and go over here, and I can go restore to point in time. And again, it looks very similar to the last one, except it will give me the exact it will give me an option for the exact time and date in which I want to do a restore. So I could go here and I could say, okay, I want March 12th, but this time I want to restore it to 10 a.m. at 5 minutes past and 10 seconds, and it will do a point in time restore to that exact point. So I'm not actually going to go and do that. I'm going to go back to my splash screen here, and we can see down here it's starting to create my new DB instance, which was my March 12th restoration. That was the full snapshot that's being restored there. So you can either restore a full snapshot or you can do point in time restoration. Okay, so if I go back to my snapshots over here, my manual snapshot has hopefully been taken, and you can see here it has been taken. It's now completed. And then if I want to, I can either migrate that, I can copy it, I can share it, I can delete it, or I can restore. If I'm going to migrate my snapshot, that can migrate it onto a different database, so we can migrate it to Aurora. But I'm just going to go back, and I'm going to go back over to my snapshots. And then we can also copy the snapshot. Now by copying it, we can actually move it to 2 different regions, which is really, really cool. So I can have for DR purposes, I can move it into Asia Pacific. And then of course we can restore it. And when we go in to restore it, I'll just go back to it for a second. And if we go to restore it, we can again restore it to different instance size class. So this is where you might decide you might want to take a manual snapshot of your database because you're looking at increasing the size of the RDS instance. In other words, you're scaling up because you need additional performance. That's the way you scale up RDS typically, is you'll take a snapshot of your database and then you'll go and change the instance class all the way up to something like an extra, an R3 8 extra large, for example. Okay, and the very last thing I want to show you is just around encryption. So you can see here that I can't restore this as an encrypted copy because my original copy was not encrypted. So if we want to create our an RDS instance that's encrypted, we just have to go in and launch a new DB instance, go across here and go to MySQL, and then we can just say use MySQL multi-AZ. Okay, so I'm just going to go in here and I'm just going to call it iCloud Guru 3. I'm just going to cut and paste that as my username and my password, and I'm going to leave everything else the same. Now if we go ahead and hit next to configure advanced settings, you'll be able to see just down here where we've got enable encryption, we can go ahead and hit yes, and then that's going to give us our master key, and that key is going to be stored using a key management service. So that's how you do encrypted RDS databases. Once that RDS database is up and running, all the data that's stored on it is going to be encrypted, and that includes your snapshots and your automatic backups. And then what you need to do is you need to take the data from your current production database and then import it into your encrypted database. So now let's move on to multi-AZ, and of course multi-AZ should be a pretty easy concept for you guys. So let's say we've got our elastic load balancer with 3 EC2 instances behind it. They will then connect into the primary RDS instance, which is going to be based in US East 1. And then what's happening is this RDS instance is going to be using a synchronous replication over to US East 2. So it's going to have an exact copy in a different availability zone. And the advantage to this is that if you lose US East 1, AWS will automatically fail over to US East 2, and it will use the same DNS endpoint. So you don't need to change the connection string on your EC2 instances. It's automatically going to fail over, and it's going to use the same DNS endpoint. So that's really great. It means that you get multiple availability zones, you get all the automatic failover, and you don't have to worry about doing any kind of connection string updates. So multi-AZ allows you to have an exact copy of your production database in another availability zone. AWS handles the replication for you, so when your production database is written to, this write will automatically be synchronized to the standby database. And then in the event of a planned database maintenance, DB instance failure, or an availability zone failure, Amazon RDS will automatically fail over to the standby so that the database operations can resume quickly without administrative interventions. You don't need to go in and change the connection strings or anything like that. It's going to happen for you automatically. So multi-AZ is for disaster recovery only, and it's really important to remember that it's not used to improve performance. It's literally for DR. If you want performance improvement, you're going to need read replicas, and we're going to cover off what a read replica is in a few slides. So multi-AZ databases are available for SQL Server, for Oracle, for MySQL, for PostgreSQL, and for MariaDB, and Aurora has basically multiple copies of your database anyway. We'll cover Aurora in another lecture in this section of the course. So what's a read replica? Now read replicas are different to multi-AZs. So let's look at our example again, in that we've got our Elastic Load Balancer, we've got 3 EC2 instances behind our ELB, and then we've got our RDS instance that's there. Now a read replica, what happens is it uses asynchronous replication, and it basically creates a exact copy of your database, except this copy you can actually read from, whereas the multi-AZ one is just there for DR, and it will automatically fail over to a different availability zone if you are going to have an outage, whereas this one you can actually use to boost your performance. So let's say that your main database has lots of reads happening to it at once, and it's very read heavy workload. What you can actually do is change the connection strings on your EC2 instances. So instead of reading from that one main database, they can actually read from the read replicas. So the top one is going to read from the read replica, the middle one's going to read from your main production database, and then the bottom one is going to read from another read replica. And what's really cool about read replicas as well is you can actually have read replicas of read replicas. So you can start scaling it out, and essentially from your main database you can have up to 5 copies or up to 5 read replicas of your main database. Now you use this when your main database is experiencing sort of very heavy read workloads. You might also use this if like management want to run their own queries on a database that's going to be really read intensive, and so what you would do is you create a read replica, and then management can run all their queries on the read replica and not your production database. You also might want to do this for test and dev purposes. You might just want to create a read replica of your main production database, so that when you're going in and doing your development environment, you can actually just read from a copy rather than from your production database. So read replicas allow you to have a read-only copy of your production database. This is achieved using asynchronous replication from the primary RDS instance to the read replica, and you can use read replicas primarily for very read-heavy database workloads. In terms of the database technologies that are supported read replicas, there's MySQL Server, PostgreSQL, and MariaDB. It's not supported using SQL Server or Oracle. So going into the exam, you're really going to need to have a good understanding of the difference between read replicas and multi-AZ databases. So just remember that read replicas are used for scaling. They're not used for disaster recovery. And you could either, if you've got a really read intensive workload, you could either use a read replica database for RDS, or you could use Elasticache. And we'll come to Elasticache later on in this section of the course. In order for a read replica to be set up, you must have automatic backups turned on in order to deploy a read replica. And you can have up to 5 read replicas copies of any database. And you can have read replicas of read replicas, but there is something to bear in mind there, that there's going to be latency considerations, because remember it's asynchronous replication, so it's got to sync over to your read replica, and then it's got to sync over from that read replica to the next read replica. So the more read replicas of read replicas you have, you're going to get higher degrees of latency. Now each read replica is going to have its own DNS endpoint, and you cannot have read replicas that have multiple availability zones turned on at this stage. So if I create a read replica, that's not going to be a multi-AZ copy. It's not going to be 2 copies of the read replica. It's always just going to be a single read replica, and it's going to be based in whatever availability zone you choose. You can create read replicas of multi-AZ source databases, however, and by that I just simply mean if you've got multi-AZ turned on your production environment, and then you want to create a read replica of your source database, you can definitely do that. And the cool thing about read replicas is they can be promoted to become their own databases. This will break the replication, but where you might do this is you're using something for test and dev, and then you decide you want to start writing to it. You basically promote that read replica to become its own unique database, and then you can start writing to it. Remember, a read replica is read only. You can't write to a read replica. And so you can also have read replicas in a second region, but that's only for MySQL and MariaDB. You can't do that for PostgreSQL. Okay, so to create a read replica, it's really simple. You just select the database that you want to create the read replica from. You click on Instance Actions and you go down and hit Create Read Replicas. Now you can actually change the size of your read replica, so it can be bigger than your original database. I'm just going to leave mine as a T2 micro, and I'm just going to call this the A Cloud Guru Read Rep. And I'm going to leave everything else as default. Here you can select what availability zone you want it to go into. So if you want your read replica to be in a separate AZ to your primary database, you can do that. And notice here you can also change the region, and that's because this is a MySQL database. So I could actually say, okay, I want my read replica to be based in Tokyo, and again, that will just give me some slightly different options, but you can then choose your different availability zones within Tokyo. So I'm going to go ahead and hit Create Read Replica. Now this read replica, in order to see it, I'll have to switch regions, but it's going ahead now and it's creating it and it's being initiated. So I'm going to hit Close, and it's just modifying, and when that goes back to available, then I'll have my read replica which has been created in the Tokyo region. So there's one last thing I want to cover off before we wrap this lecture up, and that's the difference between DynamoDB and RDS. So you've noticed that when we're creating our snapshots, when we're creating our read replicas, etc., we can always change the instance size and we can always scale up, but in order to do it, it's a manual process. We have to physically go in, create our snapshot, restore our snapshot to a new DB instance, and change the instance size when we're doing that restoration, or when we're creating our read replica, we need to change the instance size. So when you're scaling RDS, it's not automatic. It requires manual intervention in order to scale, and you can only really scale up. You can scale out, but it's only in terms of reads. You can't scale out in terms of writes. So often in the exam, you're going to get all these different scenario questions, and they will be asking you whether or not you should be using RDS or DynamoDB. Now, if you want automatic scaling or push button scaling, which means you can scale your database on the fly without any downtime, you always want to choose DynamoDB over RDS. With RDS, it's just not as easy to scale. Usually you have to use a bigger instance size or to add a read replica, and it is a very manual process. So that's something you should bear in mind going into the exam. Now we're going to explore DynamoDB in a lot more detail in another lecture. So that's really it for this lecture, guys. If you have any questions, please let me know. If not, feel free to move on to the next lecture. Thank you.